Hello guys, so in today's video we're gonna do the 10 problems on coloring proofs. If you want the concept, look at my previous videos and also view the modular arithmetic and um, the invariance concept. So let's just dive right in for this one. An 8 into 8 chessboard has two opposite corner squares removed. Can the remaining 62 squares be tiled by 31 dominoes, each covering two adjacent squares? Okay, there's always a color imbalance for these cases. If you see two opposite corners are removed, right? Which means two same color tiles are removed. It's either two white or either two black. It's either two white or else two black, right? So there's always a color imbalance when you take a domino that is the adjacent square. You'll get one black, one white, and one black, and you can't do this because you have a coloring imbalance. So it's not possible. And that's the answer for this one. A 10 into 10 chessboard is colored like a chessboard. Well, one black and one white square are removed. Can 50 dominoes cover 98 squares? Okay, here, one black and one white. One domino contains one black and one white. Uh, we have 49 black and 49 squares equal counts, so there's no it's 49 black and 49 white, right? So there's no color imbalance as uh, one black and one white square are removed. So as you don't have any color imbalance, it's completely possible, and that's the answer for this question. So a rectangle is divided into unit squares, each colored black or white, show that if number of black is not equal to number of white, the rectangle cannot be tiled by dominoes. Okay, a rectangle is divided into unit squares, right? So each color black or white. So there should always be a color balance. When number of black is not equal to number of white, there's a very big color imbalance. And if you take a domino, uh, there's one white and one black, which is black is equal to white, and it works only if black is equal to white. So it's proved, and that's the answer for this question. So the fourth question: column 8 into 8 chessboard. Odd columns equals black, even columns equals white. Can the board be tiled by 1 into 4 rectangles? Okay, so imagine the chessboard uh, the first column is white, and then black, white, black, and again white, black, white, black, right? So white, black, white. Oh, even columns are white. I'm sorry. Odd columns are black, right? So black, white, and again black, white, black, white. Black, white, black, white, right? It's tongue twister. So when you take a 1 into 4 rectangles, you have a black, white in there. So if you take two 1 into 4 rectangles, you'll cover a row. This is black, white, and again black, white. So if you perform this for 18 rows using 16 of these 1 into 4 rectangles, you'll be able to do this. So it's possible. And that's the answer for this question. So problem 5. A standard 8 into 8 chessboard has two adjacent squares removed. Can the remaining 62 squares be tiled by 31 dominoes? Okay, they give two adjacent squares, which means one black and one white are removed. And the 31 dominoes means 62 squares, right? So the remaining 62 squares can obviously be done because dominoes means one white and one black. So this is completely possible because there's literally no color imbalance identified. See, so far I haven't performed the coloring stuff yet because that's not needed in most of the questions. Only in rare questions where you might not be able to do it, there coloring comes. But in most of the cases, no. 77 chessboard has 10 square removed, leaving 48 square. Can it be tiled by L-shaped pieces covering three squares? Okay. first of all, there are 16 terminals needed because 48 squares has to be covered, and 48 by 3 is 16 terminals, 16 L-shaped terminals. So now we get okay, let me think. Okay, we can't do is because one terminal contains either two black and one white, or else two white and one black, and the standard for all. And when you keep on adding them for two dominoes, I mean two terminals, three terminals, either black or white dominates ultimately. So this is definitely not possible because of the color imbalance. That's it. That's the answer. It's impossible. A 5 into 5 chessboard is colored, uh, okay, 5 into 5 board is colored like a chessboard, can cover, can be covered by 8 dominoes and exactly one monomino. Okay, there's actually a question mistake here. I'm sorry. Actually, I think I got it wrong. I mean, this question is wrong. This must be 12 dominoes, I think. Then only you'll have 25 squares, first of all. 5 into 5 is 25. So, 12 dominoes gives you 24 pieces, and one monomino, I mean, monomino, okay, whatever, gives you one. So finally you'll get to 25. So after the one domino contains one black and one white, so there's a color imbalance, and everything can be tiled perfectly except the center. You leave the center, and if the monomino is a black square, then this applies because uh, in 8 into 8 says 4, you might be confused. There are 4 pieces with 2 black or 2 white and 2 black. If you get any I mean, if you get any odd orders of the chessboard, the center will always be black. So you just choose black in the monomino, then you'll be completely able to do it. So that's the answer. Problem 8. Every point of the plane is okay. This is pigeonhole principle. Okay, I promise to come back to this after I teach the theory, because pigeonhole principle is not like invariance and modular arithmetic and coloring, which just needs some intense logic and some basic mathematical background. Because pigeonhole has some heavy theory parts, so I promise to cover it later after uploading the pigeonhole principle tutorial. So every positive integer is colored red or blue. Show that there exists ABC of same color with a plus b equals c. So now this is a very easy question. You can just take some examples. Take 5 integers, 1, 2, 3, 4, 5, and 1 plus 2 is 3, and we can have 1 and 2 are same color, right? Because one and two red, 1, 2, and 3 red, and 3 can also be blue. If 3 is blue, we can do. We just need consecutive numbers if 3 is blue, right? So 3 plus 2 is 6, 3 plus 2 is 5, and 2 plus 2 is 4. We just get a consecutive numbers. So 4, 5, 6. So 1 is red and blue is blue. I mean 2 is blue. Then check 2 plus 2 is equal to 4, 1 plus 1 is equal to 2. So already blue, right? So you can't quite contradict this fact. And as the sequence get bigger and bigger, you know, this whole sequence that is n is large enough that a mono triple exists. So this is more like a statistics question. Like after you complete the first part, you do statistics. The n is large enough to contain at least one mono triple. Okay, so that's this. So that's the answer. Last question. Again, statistics. Now we're using more intense statistics in here. So for positive integer n, color each of 1, 2 up to 2n in two colors, say A and B. Okay, let's just take it blue and green. Okay. Condition: every n plus 1 consecutive integers contain both colors. Okay, again, now, for example, let's take n as 1, right? So there are two numbers, n plus 1 is also 2, so there are just 1 and 2. and we can have one as green and two as blue, or one as blue and two as green, whatever. And as it gets bigger and bigger, this uh like consecutive, right? So this whole sequence is large enough to have at least one single damn consecutive integer, which uh works for the question, even if n becomes bigger. So first of all, for these type of questions, you first take some examples and derive the answer. And as you know the answer is actually right, you can then say this is large enough, and you can use statistics. We don't need to know statistics. We just need to know to take what examples we need. So we just took examples. We finally concluded this is possible and reasoned it out with statistics. That's it. Simple, right? So that's it for today, guys. So like and subscribe to my channel. And tomorrow I'll be uploading Python, like a wide variety of concepts will be uploaded tomorrow for Python. So we have some catching up stuff to do, right? So like and subscribe to my channel. For today, that's it. Bye. See you tomorrow.